In this lesson, we're going to look at the continuity of functions, and I'm assuming that most of you have an idea of what continuity means, but basically at an algebra level, let's say, not using the definitions of calculus. And so I'd like you to slide to the next page. We'll come back to that first page and look at the definition after we do a little exploration. I think that most of you were given a definition of discontinuity as a place in a graph where the graph has a gap or a vertical asymptote or a hole, some type of jump. Other students have been told that if you try to trace a function and you have to lift your pen or pencil off of the graph, then you have a point of discontinuity. So what I'd like you to do, we're first going to look at the interior points. So we've got a function that's on the interval from 0 to 4, from x equals 0 all the way to x equals 4, but we're going to focus on just a few integer values of when x equals 1, 2, and 3, and these are considered interior points, not endpoints. So what I'd like you to do is just state yes or no right above the x value, right down here, whether you think the function is continuous or not continuous at that point. So pause the video, write yes or no for x equals 1, x equals 2, and x equals 3, and then start the video again. So if you had x equals 1, you had no, x equals 2, you had no, and x equals 3, you had yes, then you're correct. But I want to discuss, using calculus, why these functions are discontinuous. This function is discontinuous or continuous at this value. So at x equals 1, what I want you to do, I'm going to have you evaluate the limit and the function at these points. So pause the video and evaluate the one-sided limits and the function value for each of these values of x, and then start the video again to check your answers. Alright, so let's compare our answers here. The limit as x approaches 1 from the left is 0. The limit as x approaches 1 from the right is 1. So that means the limit does not exist. F of 1 is equal to 1. Okay. All right. So let's look at the next value, x equals 2. The limit as x approaches 2 from the left is equal to 1. The limit as x approaches 2 from the right is also 1. So here the limit exists, and f of 2 is equal to 2. Right. The last scenario, the limit as x approaches 3 from the left is 2. The limit as x approaches 3 from the right is also 2. And f of 3 is also 2. So we're going to look at the three different scenarios. Right? Where we have continuity, the left and the right hand limits were the same, meaning that the limit actually exists. And not only does the limit exist, the limit is 2, it also equals the function value. In this last case, we have the limit as x approaches 3 of f of x is equal to f of 3, and this is the main definition for continuity. If your limit equals your function value at a point, you have continuity at that point. So let's look at the first two scenarios where we did not have continuity. At the first point, x equals 1, the limit didn't exist. So since the limit has to equal the function value, the limit has to exist in order for that to happen. So if a limit does not exist at a point, then you automatically have a discontinuity. In the second scenario, the limit did exist. The limit was equal to 1, but the limit did not equal the function value. So even if your limit exists and your function value exists, if they're not equal to each other, then you have a point of discontinuity. So let's go back and look at the definition on the first page. And right now we're still talking about an interior point, and then I'll talk about an endpoint. But basically, a function is continuous at an interior point C of its domain if the limit as x approaches c of f of x equals f of c. Now this basically means three things. So by saying the limit as x approaches c of f of x equals f of c, the left-hand side means this, that the limit as x approaches c from the left has to equal the limit as x approaches c from the right, and those values, right, which are the actual limit, have to equal the actual function value. So in its most simplest form, we say the limit of f of x as x approaches c equals f of c, but you also know that this is a two-sided limit, so the one-sided limits have to be equal. They also have to equal the function value. And the only difference in this definition for an endpoint is just that for an endpoint you only have to approach from one side. So the limit, if we look at the endpoint A, the limit as x approaches A from the right has to equal f of A for a left endpoint. And for a right endpoint, the limit as x approaches B from the left has to equal f of B. So you only need a one-sided limit for the endpoints. And now that we know the definition of continuity at a point, we can talk about continuity basically by saying if a function, in order for a function to be continuous on a closed interval, it has to be continuous at everywhere in the open interval, and it also has to be continuous at the left endpoint from the right, and it has to be continuous at the right endpoint from the left. So if a function is continuous on an open interval, then we don't care if it's the continuity at the endpoints doesn't matter. So for an open interval, you don't have to have continuous endpoints, but for a closed interval, you have to have continuity not only on the interior points but also at the endpoints. And so these definitions can be modified to apply to different scenarios where you have a closed interval on one side and an open on the other, both closed, both open. So what I'd like you to do at this point, let's go back to just the endpoints of this last problem. And so when we look at x equals 0, we have continuity at x equals 0 because the limit as x approaches 0 from the right, remember this is a left endpoint, so I'm approaching it from the right, that's equal to 1, and f of 0 is also equal to 1. So we have continuity at the endpoint where x equals 0. We also have continuity at the endpoint x equals 4, because the limit as x approaches 4 from the left is equal to 1, and f of 4 is also equal to 1. Right. So for endpoints, you only need a one-sided limit that has to equal the function value. Actually, at this point, I think we'll end this video, and then in the next video, we will look at some examples where you find the intervals of continuity.